Okay, so we did not do our exit slip today, so you can take that off of our docket. Okay, here's our Plickers EOC. The correct answer was B. All right, the sum of an arithmetic series. Some definition. A series is when you're adding up all the terms, and if it's an arithmetic series, it means that it was an arithmetic sequence, and now instead of commas, we're putting plus signs in between them. So, finding the first 100 positive integers. All right, so what Gauss decided was in elementary school, when the teacher told them, the elementary kids, to add up the first 100 numbers, he decided to do it a little bit differently. He added the first and the last number together and got 101. And then he added the second number and the second to last. And if we kept doing that and pairing them up, we would have 101 every time, and there would be 50 pairs of those. And so the sum, 5,050. And so from that, we get this formula. We get that the sum is the number of terms is n. A sub 1 is the first term, and A sub n is the last term. So, to find the sum of the first, this is a typo. We're going to find the sum of these positive even numbers. So again, if we think about how many pairs we would have, so there's 25 numbers across. And each one of these would be 52, 52, etc. So we're going to have S of 25 terms is 25 over 2 times the first term plus the last. So there would be 12 and a half pairs, and each pair would add up to be 52. So again, we would just multiply that out. 650. Now you can, in your calculator, you can put 2 plus 4 plus 6 plus 8 plus 10. But again, that's going to take quite some time. All right, the next one, find the sum of the arithmetic series. Find the first 3 terms of the series in which the first number is 9, the last is 105, and S of n is 741. So we're kind of going a little bit backwards now. We're going to substitute into our formula. So we don't know n, but we do know S of n. So we're going to put 741 equals n, which we don't know, over 2. A sub 1 is 9, and the last number is 105. We're going to solve for n. So 741 and kind of clean this up. So that's 114 over 2, multiply across, n. 114 divided by 2 is 57. So we're going to have 13 terms. So we have 9 plus all the way up to 105. And this is going to be the 13th term. And this is the first. So from yesterday, since it's an arithmetic, okay, so now if we want to find these missing terms in here, what we can do is we're going to subtract the last minus the first. And then how many times are we going to have to jump to get to the next term? There's 13 terms, so that means we're going to jump 12 times 13 minus 1. And that's going to give us our common difference. 96 over 12. So there's our common difference. So now we know that we're counting by 8. So 9 plus 8, 17. 17 plus 8 is 25. So there's our first 3 terms. We have some notation. This Greek letter is called a summation or a sum. And what this does is it gives us an equation, and it tells us that we're going to start with 5 to evaluate. So this is going to be our start. And we're going to end by putting in 8. And we're just going to count up as we go. And we're just going to be able to list all the terms in the series. So we're going to do 3 times 5 minus 4 plus, now we're going to put in 6. And we're going to put in 7. And we're going to keep going until we get to 8. And then we just evaluate all that. So this would be 15, and I suppose it's 11, 14. No, I'm sorry, that's not right. Yeah, 17, and then 20. Also, keep in mind, see how the slope of this equation is 3? So that tells you that you're going up by 3 to get to the next term. And then we're just going to add all that together in our calculators. Now this only works if the span between the start and the end are relatively small. So we're going to get 62. I mean, it would work if the span's really big, but again, it's going to be like super time consuming. So what if the span is between the start and the end value is really large? So that's what we're going to have to look at. If that's the case, you're going to evaluate for the first term and the last term, and then we're going to use the formula that we just learned today. So if we put in the first term, so we're going to start with 1. And then the last term is going to be at 50. So we get 200 for the last term. Now we're going to use our formula to figure out what the sum would be all the way through. So we're going from 1 to 50, so that would give us how many terms? So we're going to go from 1 to 50, so it's going to give us 50 terms all together. First term plus last. 496 plus 200, 696, and then 25 times that. $17,400 would be the sum. Now notice that this has a slope of -6. So it makes sense that my first term is bigger than the last. It's going down. If you looked at the actual sequence, the associated sequence.